Okay, so this is a tree diagram question from 2021 exam. How do you know that it's a tree diagram question? Well, it's not going to have a table or any wording that suggests that it's a normal distribution like mean and standard deviation. In this question, if you just pause and read, you will see that there are two groups of customers. So those two groups will be our main branches to start with. We've got older customers and younger customers. And then we also have both groups ordering coffee with either cow's milk or alternate milk. So that will be our second branch. Okay, so older 40% are younger customers, which makes older customers 0.6 because both numbers on the branches must add to 1, like 100%. 1/4 of young customers request alternate milk type. 1/4 as a decimal is 0.25. For now, I'm just going to stick with decimals. So that goes here, which makes cow's milk 0.75. 80% of the older customers order coffee with cow's milk, so 0.8, which makes alternate 0.2. Of the young customers who ordered a coffee with alternate milk, 15% ordered soy milk. So young customers, coffee with alt, and that's soy. Well, we don't know what the other milks they could have ordered. So I'm just going to leave that as not soy and not assume that it's almond or coconut or oat or whatever. Half of the older customers who ordered a coffee with alternate milk ordered soy. So that's 0.5, which makes not soy 0.5 as well. Cool. So to answer the question, I was going to say order the question. Customer in the cafe is young and orders a coffee with cow's milk. So probability that they are young and they order coffee with cow's milk. When we see the word and, we have to multiply those individual probabilities. In this case, 0.4 times 0.75 gives us 0.3. Next question, find probability, orders coffee with soy milk. So see how they've said random chosen customer. They did not say whether they're old or young. So it could be old or it could be young. So keyword being or. When you see the word or, you add. So for that, we first need to calculate old and soy milk as well as young and soy milk, which means we also have to consider them ordering alternate milk. Alright, and then add the answers up. So old, alt, and soy is 0.4, 0.6 times 0.2 times 0.5. Same thing with probability of young, alternate, and soy is 0.4 times 0.25. And then we'll add the answers up. which gives us 0.06, and this gives us 0.015. Adding them up, we get also remember to put your final answers in a sentence. So you could just say probability random chosen customer orders coffee with soy milk is 0.075. Out of the customers who requested an alternate milk, what percentage order a coffee with soy milk? Yeah, so far we've only dealt with decimal numbers. When they want, or when the question specifies you to answer your final answer is a percentage, just remember to multiply your final answer by 100. So in this case, what did they want? Out of all the customers who requested an alternate milk, we don't know that, but we do know how many people ordered coffee with soy milk. That's the answer from previous question, 0.075. So we now need to calculate how many customers, or the proportion of customers who ordered coffee with alternate milk. Could be old, could be young. So scroll back up. We are now therefore looking for old and alternate milk, or young and alternate milk. Okay, so that is going to be, I tell my students to put, if you're going to calculate it all in one go, then make sure you have brackets around it, just because bit mess. So in this case, it could be young and alternate milk, or old and alternate milk. So young and alternate would be 0.4 times 0.25 brackets 0.6 times 0.2, and that gives us 0.22. Alright, that's not the final answer though. So out of all of these people, how many of them order a coffee with soy milk? So 0.3409 la la la, rounding up. So multiply that by 100, gives us 34%, rounded, of course. So just remember to put that into a sentence: percentage of coffee with from old milk, 34%. I'm gonna quickly check that answer. Yeah, 34.1 or 34%. Yeah, because we rounded, so that's fine. Probability that a randomly selected customer orders an almond milk coffee is 0.066. Of those who requested alternate milks were equal proportion, those ordering la la la, while the rest of the customers ordered a coffee with coconut milk. Okay, how many times more likely? Alright. This looks like a beast of a question. First of all, we don't know what exactly the proportions are of people that ordered coffee with almond milk. We also don't know coconut milk, but the final question is asking for coconut milk. So we first need to find those two out. What we do know is the probability that a randomly selected customer ordered an almond coffee milk is 0.06. Randomly selected customer, meaning could be old, could be young. So we first need to redraw the tree diagram and then extend it to add the coconut and almond coffee. So to extend the original tree, we now have these three branches for the alternate milks. So that's 0.15 stays the same, 0.5 also stays the same. What we don't know is almond. And if we figure out almond, then we can figure out coconut because all those three probabilities must add to 1. So we know that the probability that a random customer ordering an almond coffee is 0.066. Okay, so could be old, could be young. So probability of old, alternate, and almond plus young, alternate, and almond all add to 0.066. That's what the question is saying. So this would be 0.6 times 0.2. We don't know what that is, so it's almond. And probability of young, so 0.4. Oh yeah, just put them in brackets. 0.4 times 0.25 times x. Yeah, so the reason why I assume that both will be x is because they were equal proportions of almond. If they were different proportions, then I can't do this. I'll have to figure it out a different way. But the almond milk proportion was the same. So this gives us 0.12. Just realized that I didn't have to work it all out because we already knew that the proportion of alternate milk was 0.22 from the previous question. But anyway, so almond milk is simple algebra divided by 0.22, which gives us 0.3. So that's the proportion of almond milk, which then makes coconut milk 0.2 for the older generation and 0.55 for the younger population. Cool. So once we have that, how many times more likely is it for a customer to order a coffee with cow's milk rather than coconut milk? So now we need to figure those two out individually. So let's go ahead and do that. So this is the young one and this is the old one. That's a proportion of cow's milk. Right, so now calculating the probability of coconut milk gives us 0.55. Once again, this is the young, that's the old, this gives us 0.079. So what they're asking is, how many times more likely is it for a customer to order a coffee with cow's milk than coconut milk? Clearly, we can see that coconut milk is the smaller one, right? So what times 0.079 gives us 0.78. To figure that out, this would be gives us 9.873. So that means customers are 9.873 times more likely to order a coffee with cow's milk than a coconut milk.